Hello and welcome to Astronomy in Space. In September, NASA officially confirmed that the spacecraft Voyager 1 entered interstellar space beyond our solar system in August 2012, when it became the farthest man-made object to do so. In this program, we take a look at what this actually means. But first, let's take a look at the highlights of the October night sky. Here in the UK, British summertime ends in the early hours of October the 27th, when we put the clocks back 1 hour to Greenwich Mean Time. Therefore, on October the 1st, the sun sets at 18:42 p.m. BST and at 16:35 p.m. at the end of the month. Likewise, the average sunrise time is 7:30 a.m. BST during the first part of the month and 7 a.m. after October the 27th. October is the start of Messier marathon season, and over 40 of these deep sky objects are on view while the nights are getting longer and colder. Charles Messier was born on the 26th of June 1730. He was a French astronomer, most notable for publishing an astronomical catalogue consisting of 110 nebulae and star clusters that became known as the Messier objects. The purpose of the catalogue was to help amateur astronomers, in particular comet hunters such as himself, distinguish between permanent misty patches in the sky. He died on the 12th of April 1817. The Messier objects on view this month include the Andromeda Galaxy, M31, at magnitude plus 3.4, just up and to the right of the star New Andromeda, and there are two conspicuous satellite galaxies, M32 and M110, in the field of view. M33 and Triangulum, which you can see in the same wide-angle binocular field as the star Alpha Trianguli, look past the fainter star 1 Trianguli, and about an equal distance beyond it, in the direction of Beta Andromeda, you will find the haze of M33, which is of magnitude plus 5.7. M64, the Black Eye Galaxy, which is a magnitude plus 9.3 spiral in the constellation of Coma Berenices, 1 degree northwest of the star 35 Coma. M31, the Whirlpool Galaxy in Canes Venatici, close to the star Alciad Eta Ursa Majoris, the lefternmost star in the Plough. It has an apparent magnitude of plus 8.4. M74 is a magnitude 10 galaxy in Pisces of Fishes. It is easy to locate with a telescope, being half a degree north and 1.5 degrees east of Eta Pisceum, the brightest star in the constellation of Pisces, of magnitude plus 3.6, and the many more star clusters in and around Cassiopeia. The lovely double cluster in Perseus near Cassiopeia is not in Messier's catalogue, yet it is a splendid sight in binoculars. And look out for Messier 45, the Pleiades and Taurus, rising in the eastern sky. The Plough, Ursa Major, is close to the northern horizon, while the bright stars that make up the W of the constellation Cassiopeia are overhead, with Cephus and Perseus nearby. Midway between Ursa Major and Ursa Minor is the widening constellation of Draco, the Dragon. The maximum of the Draconids meteor shower takes place between October the 6th and the 10th. The Draconids is a small meteor shower with only about 10 shooting stars per hour. It is produced by the dust grains left behind by comet 21P Giacoboni-Zinner, which was first discovered in 1900. In the south, the great square of Pegasus is on view, with the constellation of Andromeda next in line. There is also Eris, Triangulum, Pisces and Aquarius, with Cetus low down in the southwestern sky. The winter constellations are now rising in the east, led by Taurus the Bull and Auriga the Charioteer, followed by Orion the Hunter. The Orionid meteor shower runs annually from October the 2nd to November the 7th, producing up to 20 meteors per hour at its peak. This will happen on the morning of October the 22nd. It is produced by dust grains left behind by Halley's comet, which has been known and observed since ancient times. The planet Mercury reaches greatest eastern elongation on October the 9th. Mercury is visible in the western sky after sunset, shining at magnitude minus 0.0, setting 23 minutes after the Sun on October the 1st and 25 minutes after the Sun on the 9th. The planet will then get lower and fainter in the dusk sky, setting 11 minutes after the Sun at the end of the month. Its magnitude will then be plus 2.4. Mercury will be 2 degrees south of the Moon on October the 6th. The planet's apparent diameter is only 6 seconds of arc, which is quite small, so a moderate telescope is needed to show its phase. It changes from 73% illumination at the beginning of October to 2% at the end of the month, when it will be a slender crescent. The planet Venus is also visible low in the western sky after sunset, shining at magnitude minus 4.1. The planet sets 1 hour 6 minutes after the Sun on October the 1st and 1 hour 35 minutes after the Sun on October the 26th, when its magnitude will be minus 4.3. The planet lies in the constellation of Scorpio and can be found 1 degree from the magnitude plus 2.3 star Delta on the 7th of October, and Venus will be 4 degrees south of the Moon on October the 8th. Venus reaches aphelion, its farthest distance from the Sun, on October the 3rd, when it will be a little over 82 million miles from the Earth. Venus has an apparent diameter of 18.5 seconds of arc, which means a small telescope will show the planet's phase. It is 63% illuminated at the beginning of the month and 50% at the end of October. The latter is called dixitomy. The significance is that from next month, amateur astronomers will be observing Venus more closely to catch a glimpse of the phenomenon called the ashen light, a subtle glow that is seen from the night side of the planet. We now come to the Moon. New Moon is on October the 5th, first quarter will be on October the 12th, full Moon is on the 19th, and last quarter is on October the 27th. Astrophotographers can look forward to a nice photo opportunity this month when the Moon lies in the constellation of Taurus, the Bull, on October the 22nd. In the eastern sky before dawn, you will see the bright orange star Aldebaran and the Hyades open cluster 1.8 degrees east of the Moon. There will also be a penumbral eclipse of the Moon beginning at 10:53 p.m. on October the 18th from many locations. A penumbral eclipse is not as interesting as a full lunar eclipse because the Moon only passes through the Earth's outer shadow, casting space. Clear skies permitting, the Moon's light will dim slightly until the event ends at 02:48 am early the next day. The planet Mars rises in the eastern sky at 2:30 am and has now moved into the constellation of Leo. The planet lies to the east of the bright star Regulus, which is located in the base of the sickle star pattern. In the sky, the sickle looks like a reversed question mark of stars. Mars shines at magnitude plus 1.8, and with its sandy hue, it makes a nice contrast with Regulus nearby, which is blue in colour and of magnitude plus 1.35. As seen through a telescope, Mars has a diameter of only 4.5 seconds of arc, so large telescopes are needed to show any markings on the planet's tiny disk. On October the 1st, Comet Ison will pass within 6.7 million miles of Mars, and therefore is the planet's neighbourly companion during the month. Here is the updated light curve of Comet Ison, as calculated by Bruce Gary of the Hereford, Arizona Observatory. The first observations of Ison are now coming in, and it looks like the comet is 3.9 magnitudes fainter than predicted. After making adjustments to the comet's ephemeris, this means that Comet Ison will be at magnitude 12.4 on October the 1st and plus 9.8 on October the 31st. Therefore, Comet Ison will only become a magnitude plus 6.4 object at perihelion, which will be on November the 28th. The comet will therefore not be a spectacular sight in the winter night sky, as previously predicted, unless something unexpected happens. The Mars Atmosphere and Volatile Evolution spacecraft, MAVEN, has arrived safely at NASA's Kennedy Space Center, and preparation for its launch on November the 18th from Cape Canaveral is advancing well. The MAVEN mission will be the first devoted to understanding the Martian upper atmosphere. The planet Jupiter lies in the constellation of Gemini, the Twins, close to the plus 3.5 magnitude star Delta Gemini. Jupiter rises in the eastern sky at 23:30 p.m. on the 1st of October and 9:42 p.m. at the end of the month. Jupiter shines at magnitude minus 1.78 and is getting brighter as it moves slowly along its celestial path. Jupiter has a large angular diameter of 41 arcseconds, so that even a small telescope will show the horizontal cloud belts, while a pair of binoculars will easily show the planet's 4 large moons, Io, Europa, Ganymede and Callisto, as we drift around the giant planet. To learn more about Jupiter and how best to observe the planet, please see last month's Astronomy space program. The planet Uranus was discovered by Sir William Herschel in 1781. It is the 6th planet in order of distance from the Sun, so when Uranus comes to opposition on October the 3rd, the planet will be 1,783 billion miles from the Sun. Uranus lies in the constellation of Pisces the Fishes, south of the plus 4.4 star Delta. It is not very bright, at magnitude plus 6, however, a pair of binoculars will show it quite well, while a 3-inch telescope will show the planet's tiny turquoise disk. Uranus is a giant gas planet, 32,193 miles in diameter, 4 times larger than our Earth, and the planet takes 84 years to orbit the Sun once. We now know that Uranus has a day 17 hours long. It has a ring system just like the other gas giants, Jupiter, Saturn and Neptune, and that Uranus has 27 moons. The 5 largest satellites are Miranda, Ariel, Umbriel, Titania and Oberon. The strangest thing about Uranus is its actual tilt of 98 degrees, compared to the Earth's 23.5 degrees. Astronomers believe that at some point in its past, a large planet or asteroid struck Uranus, pushing the planet over. Now an update about Nova Delphinus, which lies in the western sky after sunset. Here is the nova's latest light curve. On September the 4th, Nova Delphinus was given its official designation of V339 Delphini. It reached its peak brightness on the 19th of August at magnitude plus 5.0, and by September the 12th it has slowly faded to magnitude plus 6.5. Since then the nova has started to get brighter, so that on the night of September the 15th it was at magnitude plus 6.1. The constellation Delphinus set at about 2:30 am during the month. Now on to our main theme. On September the 12th, NASA issued a press statement confirming that Voyager 1 first entered interstellar space in August 2012 and has been travelling for about 1 year through plasma or ionized gas present in the space between the stars. Voyager 1 is in a transitional region immediately outside the solar bubble called the heliosphere, where some effects from our Sun are still felt. 36 years ago, on the 20th of August 1977, Voyager 2 was launched towards the outer planets from Cape Canaveral on a Titan III rocket. Then on September the 25th, Voyager 1 was launched on its epic voyage to the extreme boundary of the solar system. Each spacecraft consists of a 722 kilogram, 1,590 pound space probe constructed by the Jet Propulsion Laboratory. Each has 16 hydrazine thrusters, 3-axis stabilization gyroscopes and referencing instruments to keep the probe's radio antenna pointing towards the Earth, and 8 backup thrusters. The spacecraft also includes 11 scientific instruments to study celestial objects such as planets as they travel through space. The cost of the Voyager 1 and Voyager 2 missions, including launch, mission operations and the spacecraft's nuclear batteries, is about £625 million. These were the Voyagers, which were destined to visit first Jupiter and then the ring planet Saturn, after which Voyager 2 would go on to rendezvous with the outermost giants, Uranus and Neptune. It so happened that in the late 1970s and early 1980s, the giant members of the Sun's family were all lined up in a way which occurs only once in every 2 centuries or so. Therefore, a spacecraft can fly past Jupiter and use a powerful pull of that planet to propel it outward towards an encounter with Saturn. Saturn's pull can, in turn, swing the spacecraft onto Uranus and finally to Neptune. Much had been heard of the so-called Grand Tour, in which all 4 planets will be visited in turn by a single space probe. The original plan was given up on the grounds of expense, but the Voyager program revived it. The main problem facing space planets or probes to the giant planets is that of sheer distance. The Earth is 93 million miles from the Sun. Jupiter's mean distance is 483 million miles, so that a journey there by a modern type spacecraft takes well over a year and a half, as against a few months for a closer approach with Mars, Venus or Mercury. So far there have been 2 successes. One of these was Pioneer 10, that was launched in March 1972 and made its closest approach to Jupiter in December 1973, sending back spectacular photographs as well as a great deal of assorted information. The other is a Cassini mission to Saturn. This spacecraft is still orbiting the ring planet, sending back a lot of exciting data and images of the planet and its moons. The closest approach of Voyager 1 to Jupiter occurred on March 5th, 1979, followed by Saturn on November 12th, 1980. On February 14th, 1990, Voyager 1 took the first ever family portrait of the solar system as seen from the outside, which includes a famous image known as the pale blue dot. On November 17th, 1998, Voyager 1 overtook Pioneer 10 as the most distant man-made object from the Earth. Travelling about 17 kilometers per second, that's 11 miles a second, it has the fastest recession speed of any man-made object. To put this into perspective, if Voyager 1 were a satellite travelling around the Earth, it would take less than 7 minutes to orbit our planet. The International Space Station takes 90. Our solar system is made up of the Sun in the centre, surrounded by 8 planets, the rocky wheels of Mercury, Venus, Earth and Mars, followed by the 4 giant planets, Jupiter, Saturn, Uranus and Neptune. Neptune lies 2.88 billion miles, over 4.5 billion kilometres from the Sun, and at the moment, Voyager 1 is more than 11.6 billion miles further away than Neptune, lying in the region we call the heliosphere. The spacecraft is so distant, two-way communications takes 35 hours to complete. While Voyager 1 is commonly spoken of as having left the solar system simultaneously with having crossed the heliopause, it remains well within the sphere of the Sun's gravitational influence. Voyager 1 is not heading towards any particular star, but in about 40,000 years it will pass within 1.6 light years of the star Gliese 445, which lies in the northern constellation of Camelopardalis. The heliosphere is a region of space dominated by the Sun, a sort of a bubble of charged particles in the space surrounding the solar system. These particles are blown out from the Sun by the Sun's solar wind and into interstellar medium, the hydrogen and helium gas that infuse the galaxy. Although electrically neutral atoms from interstellar space can penetrate this bubble, virtually all of the material in the heliosphere emanates from the Sun itself. The Sun's corona is so hot that particles reach escape velocity, streaming outwards at up to 800 kilometers a second, 1.8 million miles an hour, producing the solar wind. The basic structure is that the wind travels outwards until the termination shock, then the heliosheath, and finally the heliopause, all of which have been unexplored until now, so that the nature of these structures are still a mystery. Short-period comets originate from the Kuiper belt, which is a region of the solar system beyond the planets, extending from the orbit of Neptune to about 4.6 billion kilometers from the Sun. Voyager 1 is presently over 18.5 billion kilometers distant and has therefore passed through the Kuiper belt region and is heading towards a donut-shaped inner Oort's cloud. At its current speed, Voyager 1 will arrive at the Oort's cloud in 2044, and it will take about 30,000 years to pass through the region. Sadly, Voyager's remaining instrument will have all closed down by 2025, so the spacecraft will be unable to tell us anything about the Oort's cloud itself, a region where we believe long-period comets come from. The outer Oort's cloud is thought to extend to over half a light year from the Sun. Here is Susan Dodd, Voyager project manager based at NASA's Jet Propulsion Laboratory in Pasadena, California, speaking recently to members of the media.
So Suzanne, you're going to tell me why an obsolete piece of equipment still continues to function.
Yeah. Thank you, Gary. Well, I'm thrilled to be here. Wow, that's about all I can say. I'll admit, like Gary, I was in high school when Voyager was launched, and I was a little more concerned about getting my driver's license than I was about watching Voyager launch at the time. But I'm excited to be here and talk to you today as the project manager. And the key point I want to make is that this mission is not over. I think you've heard all of my previous speakers tell you how much more science is out there yet to come. And many, many more discoveries are out there yet to come as well. If we can roll the first graphic. So Voyager was launched at a time where it could take advantage of a unique trajectory, which happens only 176 years. It could reach all the outer planets in a 12-year time period. The last time that could have happened was during Thomas Jefferson's administration. So Voyager 1 went by Jupiter and Saturn. That was the original mission. And then Voyager 2 was able to continue on to Uranus and Neptune. Between the two Voyager spacecraft, they discovered 23 moons of the outer giant planets. And today, Voyager is traveling away from us in interstellar space at over 38,000 miles per hour. Now, the Voyager spacecraft is old, and because of that, the science team who works on it are what we like to call well-seasoned. And if I can have the slide, the Team 1 slide. This is an image taken from 1972. It's the first Science Steering Group meeting held at the Jet Propulsion Laboratory right after the project was started. You could probably pick out Ed Stone. He's in the front row, the second from the left. His hair is a little darker, and he's looking pretty good as well as the rest of the science team there. And if I can have the next team picture, you'll see how we look today. Okay, so this image was taken on Monday, and it's nearly 40 years after the previous image. And this is the science team. There's about 12 engineers back at JPL who operate both spacecraft. And they've been with the project nearly as long as all the scientists. And what I can tell you about this group is that they are extremely passionate about their science. They are as passionate today. They argue, they banter at each other, they go back and forth at it in these science team meetings, and they're just as passionate today as they were in 1972. So one of the things I want to give you a sense for is the technology and the age of the Voyager spacecraft. So the Voyager spacecraft has only 68 kilobytes of memory on board. Now, I'm going to pull out my smartphone, which all of you have. Okay, this has 240,000 times more memory than the Voyager spacecraft. Okay, but it's the little spacecraft that could, we keep on going. We communicate with the spacecraft every day, both spacecraft every day, and we use the Deep Space Network that's run by NASA. And really, I would say the Voyager and the DSN have grown up together. The DSN has been with us the whole time. Voyager is currently 11.6 billion miles away from us, and the signal from Voyager to the Earth takes 17 hours and 22 minutes one way. Okay, Voyager transmits with a 22-watt transmitter. Okay, that's about the size of your refrigerator light bulb. Okay. When that signal comes down and the DSN picks it up, it's 1/10 of a billionth of a watt. Now, back in February, we were fortunate to have another observatory, the Very Long Baseline Array, which is operated by the National Radio Astronomy Observatory, try to look for Voyager's radio signal. Voyager was 11.5 billion miles away last February, and the VLBA went out there and looked for the signal. If you can bring up the next graphic, they were able to see a blue speck, and this image represents the Voyager radio signal as seen by the world's most sensitive ground-based telescope. It's just a speck in amongst the sea of darkness. Now, I mentioned earlier that this mission can continue for several more years. We use radioisotope thermoelectric generators. They were provided by the Department of Energy. They decay at 4 watts per year. In other words, they lose 4 watts of power per year. So as a project manager and the engineers on Voyager, we have to be very careful to manage that power source so that we can continue to operate the instruments for as long as possible. And we have enough power to operate the fields and particles instruments, which are taking the current interstellar data out till the year 2020. So that's 7 more years we can operate these instruments. And then after the year 2020, we'll be turning off 1 instrument at a time until the year 2025, when all the instruments will go off. But that gives us a good 13, 14 more years to operate the Voyager spacecraft and get science data back from them. We can operate the spacecraft about 10 more years afterwards if we just want to take down engineering data. So where is Voyager going? If we can have the next graphic, that's where Voyager is going. Okay, that star is AC plus 79, 38, 88. Voyager is on its way to a close approach with it in about 40,000 years. It's going to come within 1.7 light years of this star, and it will swing by it, and it will continue to orbit around the center of our Milky Way galaxy. And finally, I just want to comment that I really feel the people who had the vision to create Voyager, who built it and who sent it on its way, they just had an extraordinary vision about the discovery and the adventure. And Voyager was built for scientists, but it's really for all of us. Voyager contains on it, each Voyager has a gold record. This gold record was designed by Carl Sagan and his team. And on this gold record are music and greetings and sounds and even images of the planet Earth from all over the planet Earth. And it's really a time capsule of us. You know, this is us contained in this record. And now the Voyager, and particularly Voyager 1, is carrying this time capsule of us into interstellar space. And we're traveling along with Voyager as it continues on this journey of discovery.
Voyager 2 is expected to keep transmitting weekly radio messages until at least 2025, over 48 years after it was launched. Voyager mission controllers still talk to or receive data from the Voyagers every day, although the emitted signals are currently very dim, at about 23 watts, the power of a refrigerator light bulb. By the time the signals reach the Earth, they are a fraction of a billionth of a watt. Data from Voyager 1's instruments are transmitted to Earth typically at 160 bits per second and captured by NASA's Deep Space Network. Voyager 1 is a splendid spacecraft, and on this historic occasion is a fine ambassador for the people of planet Earth. At some time in the future, Voyager 1 will be discovered by an alien race who will at once know we are not alone in the universe. I wonder what they might think about Voyager 1. Just time to mention that the October edition of the BBC Sky at Night programme will be broadcast on BBC One on the 6th of October around midnight and will be available on the iPlayer catch-up service soon after. This month, the team travelled to Mid Wales to attend a star camp on the Brecon Beacons. That's all we have time for this month. Thank you for watching. Until November, goodbye for now. M31 at magnitude plus 3.4, just up and to the right of the star New Andromeda, and there are two conspicuous satellite galaxies, M32 and M110, in the field of view. M33 in Triangulum, which you can see in the same wide-angle binocular field as the star Alpha Trianguli, look past the fainter star 1 Trianguli, and about an equal distance beyond it, in the direction of Beta Andromeda, you will find the haze of M33, which is of magnitude plus 5.7. M64, the Black Eye Galaxy, which is a magnitude plus 9.3 spiral in the constellation of Coma Berenices, 1 degree northwest of the star Sagittarius Coma. M31, the Whirlpool Galaxy in Canes Venatici, close to the star Alciad, Eta Ursa Majoris, the lefternmost star in the Plough. It has an apparent magnitude of plus 8.4. M4 meteor shower with only about 10 shooting stars per hour. It is produced by the dust grains left behind by comet 21P Giacoboni-Zinner, which was first discovered in 1900. In the south, the great square of Pegasus is on view, with the constellation of Andromeda next in line. There is also Aries, Triangulum, Pisces and Aquarius, with Cetus low down in the southwestern sky. The winter constellations are now rising in the east, led by Taurus the Bull and Auriga the Charioteer, followed by Orion the Hunter. The Orionid meteor shower runs annually from October the 2nd to November the 7th, producing up to 20 meteors per hour at its peak. This will happen on the morning of October the 22nd. It is produced by dust grains left behind by Halley's comet, which has been known and observed since ancient times. 74 is magnitude 10 galaxy in Pisces of Fishes. It is easy to locate with a telescope, being half a degree north and 1.5 degrees east of Eta Paucae, the brightest star in the constellation of Pisces, of magnitude plus 3.6. And the many more star clusters in and around Cassiopeia. The lovely double cluster in Perseus near Cassiopeia is not in Messier's catalogue, yet it is a splendid sight in binoculars. And look out for Messier 45, the Pleiades and Taurus, rising in the eastern sky. The Plough, Ursa Major, is close to the northern horizon, while the bright stars that make up the W of the constellation Cassiopeia are overhead, with Cephus and Perseus nearby. Midway between Ursa Major and Ursa Minor is the widening constellation of Draco the Dragon. The maximum of the Draconids meteor shower takes place between October the 6th and the 10th. The Draconids is a small Hello and welcome to Astronomy in Space. In September, NASA officially confirmed that the spacecraft Voyager 1 entered interstellar space beyond our solar system in August 2012, when it became the farthest man-made object to do so. In this program, we take a look at what this actually means. But first, let's take a look at the highlights of the October night sky. Here in the UK, British summertime ends in the early hours of October the 27th, when we put the clocks back 1 hour to Greenwich Mean Time. Therefore, on October the 1st, the sun sets at 18:42 p.m. BST and at 16:35 p.m. at the end of the month. Likewise, the average sunrise time is 7:30 a.m. BST during the first part of the month and 7 a.m. after October the 27th. October is the start of Messier marathon season, and over 40 of these deep sky objects are on view while the nights are getting longer and colder. Charles Messier was born on the 26th of June 1730. He was a French astronomer, most notable for publishing an astronomical catalogue consisting of 110 nebulae and star clusters that became known as the Messier objects. The purpose of the catalogue was to help amateur astronomers, in particular comet hunters such as himself, distinguish between permanent misty patches in the sky. He died on the 12th of April 1817. The Messier objects on view this month include the Andromeda Galaxy,